Welcome back to eCoreAcademy, everyone. My name is Anita and I am one of the teachers and co-founders here. As you can see, I have another Algebra 2 lesson prepared for all of you, and this, I promise, is going to be the very last video in our quadratics unit before we move on to the next unit, which is all about polynomials. So in this last lesson, you can see it's quadratic systems continued. If you watched the previous video, you'll see that I did one on quadratic systems. If you all remember from Algebra 1, we were solving linear systems of equations where you had two lines on a coordinate plane and their point of intersection, which was a coordinate point, was the solution to that system. So that coordinate had an x-coordinate and a y-coordinate, which when you inputted into the linear equations of those two lines in that system, it solved and it worked for both of them. So it was a point that lay on both of those lines. So you had instances where you had one intersection, you had infinite intersections of the two lines lay on top of each other, and they were both the same line, or you had no solutions if those lines were parallel and they never touched at all. In this case, with quadratic systems, we're not only going to be working with lines, but we're also going to be working with parabolas, which is the shape that a quadratic equation makes when you graph it on a coordinate plane. And on my last video, we talked about graphing. So we did one problem where we had a quadratic equation and we had a linear equation. We graphed them and we found the solution to that. We found the two solutions to that problem by graphing. Then we did another problem where we had two quadratic equations and we solved by substitution. And the last problem we did was inequalities. So we had two quadratic inequalities instead of equations, and we graphed those on the coordinate plane, and we found the region which contains all the viable solution sets. In this video, don't think of this video as a part 2. Think of it as like AJ's extended problems that he does in geometry. This is going to be a continuation off of that because there are two parts that I do want to cover that I did not cover in the last video. One is a TI calculator section, and the other is a summary. So it's going to be like pretty much summing up exactly how we've been solving quadratic equations in this unit. So I'm going to be giving you a very good summary, and I would copy that down in your notebook, and you could use that almost like a cheat sheet or a flashcard to always remind you how to approach any quadratic equation you come across. Because over the course of all these videos I've made, hopefully you've seen that quadratic equations can come in such a diverse amount and a diverse arrangement that you have to be able to approach all of them in anything that's thrown at you. So here we're going to be continuing to find solutions to systems of equations that include both linear and quadratic functions, hence quadratic systems. But before I even get into this video, please make sure you hit the like button, hit the subscribe button, hit the post notification bell, drop a comment down below, and share using our socials. So let's get into the TI calculator section now. Okay, everyone, as you can see, I've switched to a view of my calculator, and now we're going to be using the TI calculator to graph and find the solution sets or multiple coordinates for a quadratic system. So here's the problem on the screen to the left. So solve the following system by using the TI. Our first quadratic equation is y equals x squared minus 7x plus 7, and in this case, we've been given a linear equation as our second equation in this system of equations, and it's y equals 5x plus 1. So let's go about solving this, but instead of actually graphing it by hand or using substitution method or any other method, let's actually have the TI calculator do the work for us. So what we're going to do is first we want to clear our calculator. To do that, remember, hit second, then mem, then second mem 7 1 2, and now you've reset your calculator. So let's go about solving this problem, and the steps are written on the chalkboard to the left. So go to your y equals and input both functions. So I'm going to go to my y equals button, which is up here. I'm going to input the first function here. The first function is y equals x squared minus 7x plus 7, so let me input that. X squared minus 7x plus 7, and let's input the second one, which is the linear equation, y equals 5x plus 1. So we're good to go. So what's the next step? Adjust the window and graph. So what we want to do is go to your window. I would crank x min, maybe let's crank it down to -30. Let's push x max to 30. Let's crank y min down to negative 30, and then y max down up to 30, pardon me. Remember, you're only changing x minimum, x maximum, y minimum, y maximum. This is going to control how low your x-axis goes, how high your x-axis goes, how low your y-axis goes, and then how high your y-axis goes. So now that we've adjusted those, let's graph and let's see. There is our quadratic, and there is our linear equation. As you can see, our linear equation actually keeps going. It's going off the graph. So what we want to do is we want to increase our y max. So let's go back to window. Let's go, just for good measure, I'm going to put it all the way up to 70 and hit graph. And let's see if we can see both points of intersection, meaning let's see if we can see both places where this line is going to cross the parabola. And as you can see, there's one down here and one up here. So we're good to go. We can see both of them. And that's the key with the graphing calculator. You want to make sure you can see both points of contact between the quadratic and the line. So what we want to do now is we want to find the exact place where the line touches the parabola. To do that, let's go to the next step. Second trace, 5 for intersect, enter. So, and you want to do that 3 times. So what in the world does that even mean? I'll break it down for you. What we're trying to do, we're trying to have the calculator find the points where they intersect and find the actual exact coordinates where these two graphs intersect, and that will be the solution sets to this system of equations. So first we want to hit the second button and then go to trace, and then we will be on the calc menu. So then we want to go to 5, and if you just press 5 on your keypad, it'll say intersect. We want to find the point of intersection. So that's been pressed. Now you see your cursor blinking. You want to hit it 3 times, and you're going to find the exact point right down here where my finger is, that exact point where the line crosses the parabola. So I hit enter 3 times, 1, 2, 3. And I've been given this point. 0.5227 is my x-coordinate, and then my y-coordinate is 3.6138. So just keep that in the back of your head, or jot that down. But don't forget that we have another point up here. And we can't forget this point because this is another solution. If you had this as a problem on a homework assignment or just an assignment in general or even an assessment, if you put down just one point when there are actually 2 solutions, you're probably only going to get partial credit. So don't ignore the second point up here. To do that, we're going to repeat the same process. So second, then the trace button, 5 for intersect, and then you have this keypad right here. You're going to utilize this so that you can actually scroll closer to the point at the top. If you don't scroll closer, you're just going to find this point over again if you repeat the process. So make sure you hit the right arrow and you can scroll up to the point up here. Hit enter 3 times, 1, 2, 3. You're going to get 11.4772 as your x-coordinate and then 58.3861 as your y-coordinate. So again, repeat for the second point, and that should be your answer, which is exactly what we got. 0.523, 3.614 is your first coordinate, and your second coordinate is 11.477, 58.386. So that is how you would solve this using the TI calculator. Before I conclude this video after that TI calculator section, I do want to go over something very important, and that is a summary of solving quadratic systems. So any quadratic equation you're given, here are the surefire steps that you should always follow in order to solve. So when solving quadratics, use the following steps. If there's only a quadratic term, then use square roots to solve. So this is what I mean. So remember, a quadratic term is always going to be your x squared term. That's what denotes a quadratic. So if you have something like this, if you have something like x squared, this is what you would consider a quadratic term. So equals quadratic term. Quadratic term. I'll give you an example of a problem that uses this principle. If there's a quadratic term, then you have to use square roots. So what exactly does that mean? So if we had something like 32, I'm making this up off the top of my head, 32 equals 2x squared. This is obviously a quadratic term because we have an x squared term. So how would we solve this quadratic equation? Well, what we want to do is we want to get the x squared term by itself. So in this case, that's always going to be your aim if you have a quadratic term. If it has a coefficient, try to get rid of that coefficient. To get rid of that coefficient, what we'd have to do is we'd have to divide both sides by 2. So 2x squared divided by 2 is equal to just x squared, and then 32 divided by 2 is equal to 16. Now is when we use the square roots to solve. So if we square root both sides of the equation, we get the square root of x squared is equal to the square root of 16. square root of x squared, the square root and the square cancel out, and you just get x is equal to the square root of 16. So this is what we mean by using square roots to solve. And remember, because we have the square root of 16, we can have both the positive or negative square root. So there are two answers. So we could have plus or minus 4. And if we plug positive 4 back into the original quadratic equation we were given, positive 4 squared is 16. 16 times 2 is 32. If we negative, we get the same. Negative 4 squared is 16. 16 times 2 is 32. So that's what you would do if you just had a quadratic term, which is that x squared term. If you have only a quadratic term and a linear term, you have to set the equation equal to 0, GCF if possible, and solve. So I'm trying to think of a situation. So if you had something like 0 is equal to 2x squared plus 4x. So if you see a linear term, think of it like a linear equation. Y equals mx plus b. The linear term is here, this mx part. So we have x to the first power. So that is what you would consider a linear term. Just like we said x to the second power was quadratic, x to the first is linear. So if you don't have that c, so remember, standard form is y equals ax squared plus bx plus c. If you have this ax squared part and you have this bx part, but you don't have this c part, this is the situation we're talking about. So what we want to do is we set it equal to 0. In this case, I already made it equal to 0. This might not always be the case. You might not always be able to set it equal to 0, but try your best. Then what you want to do is you want to GCF, so you want to pull out the greatest common factor. In this case, we can say the greatest common factor is 2 for the coefficients, because 2 divided by 2 is 1, and 4 divided by 2 is 2. And then you can also factor out an x, because both of these terms have x's. So you can factor out 2x, GCF out 2x, and then you get 2x times x plus 2. So if you multiply this back out, 2x times x is 2x squared, plus 2x times 2 is 4x. And then what we can do is we can set each of these parts equal to x. So 2x is equal to 0, so x is equal to 0 because you divide both sides by 2, and 0 divided by 2 is 0. Then you get x plus 2 is equal to 0, and you subtract 2 from both sides, you get x is equal to negative 2. So these would be your two answers. So that's how you would solve a situation where you had a quadratic term and a linear term. You would try your best to set it equal to 0, GCF if possible, and then you would solve it normally. If it is a perfect square trinomial, write it as a binomial square and use square roots to solve. So reminder, this is a perfect square trinomial. So a plus b squared is equal to a plus b times a plus b. And then you could have a minus b squared is equal to a minus b times a minus b. And my best example for this would be something where you have a situation like 0 equals x squared plus 10x plus 25. So this here is a perfect square trinomial, because if we factor this out, we can see 0 is equal to x plus 5 times x plus 5. And if we multiply x plus 5 times x plus 5 out, we get x squared plus 10x plus 25. What you want to do is you want to write it as a binomial square. So, and then use the square roots to solve. So we can write it as 0 is equal to the quantity x plus 5 squared, because it's literally just this expression multiplied by itself. We can use square roots to solve. So the square root of 0 is 0. Square root of quantity x plus 5 is just x plus 5, because the square root cancels out. You can subtract 5 from both sides. You get x is equal to negative 5. Remember, perfect square trinomials only have one solution. That's how you'd solve a perfect square trinomial. Reminder, if it factors, then factor and solve. So if you don't have a perfect square trinomial, but you do have another situation where you can factor, then just simply factor it, which I made a series of videos on, so go check those out. And if it does not factor, then complete the square or use the quadratic formula. Remember, when you complete the square, you're taking that bx term, you are taking the b, you are dividing it in half, you're adding and then squaring it, and then adding that to both sides of the equation. Then you are going to force a perfect square trinomial, and then afterwards, what you're going to do is you are going to break it down, factor, and then you're going to solve normally. As for the quadratic formula, this is always your go-to. So your quadratic formula you can always use to solve any quadratic equation at all. So you usually resort to the quadratic formula when you absolutely cannot factor, you cannot do anything at all, because it does involve quite a bit of work. And here's the formula: x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So that's a quick summary of solving quadratic systems, and I hope that was helpful. I would highly, highly recommend you copy this down, or you take a picture of it, or you just remember these steps, because it will help you approach any problem. Think of it like a checklist that you're going down. Whenever you hit a bump, that's the step that you're going to have to use. Okay, and that's all I have for you today. I hope you liked this continuation, and I really do hope it was helpful, because I included some things that I did not include in the last video. If you did like this video, please like, subscribe, and hit the post notification bell. Also, drop a comment down below. Share using our socials, including Facebook, Twitter, and Instagram. We also have a website, so please check that out whenever you can. It has a bunch of sweet functionalities, and it has all of our courses. So again, check that out. And lastly, if you have any personal or business correspondences, please reach out to us at eCoreAcademy@gmail.com. Thanks for watching, and look out for my next video. Bye!